here they have given W ammonia plus X O2 to give you YNO plus ZH2O. Okay, so I'm going to actually teach you how to balance this reaction using oxidation number. Now, if you want to balance that, first you have to identify which one is reduced and which one is oxidized. In order to do that, you need to calculate the oxidation numbers. Okay, so I'm going to actually quickly calculate the oxidation number here. Okay, this N, okay, the N, okay, you can calculate X. Okay, hydrogen is always plus 1, so it's going to be 3 times 1 equals to 0, X equals to -3. And then the N over here, okay, this one if you calculate is X minus 2, oxygen is always -2 equals to 0, X equals to 2. So you can see that, okay, from here to here, okay, that's going to be -3. They are going to become 2, and you can see that it's going to be increase in oxidation number. So it's going to be oxidation. I have identified that is going to be oxidation. So I'll write down the oxidation. This is going to be the equation involving oxidation. So ammonia, okay, ammonia is going to give me NO. Okay, and then I will identify the reduction. So of course you have to, if you look over here, it's actually related to oxygen. This is going to be oxygen. Okay, in element is going to be 0 oxidation number. This is going to be -2. So you can see from here to here decrease in oxidation number. So this one is going to be reduction. So I will write down, okay, this is going to be reduction. So this using the oxidation number, I found out which one is oxidation and which one is reduction. So I will write down, okay, this is going to be the reactions that I will get. Okay, so the next part is, okay, under oxidation, if I look at the number -3 to become 2, the increase in oxidation number, that is going to be increased by 5 units. -3 plus 5 is going to be 2. So there's going to be increased by 5 units in oxidation number. And then if you look at the oxidation number for oxygen, there is going to be decreased by 2 units. So I will write down -2. Now, when it comes to the definition for oxidation and reduction, you can remember oil rig. Okay, oxidation is loss of electron. Reduction is gain of electron. So in this case, now we are going to use the electron to identify and try to solve this reaction. So here, when we have +5, okay, it means that the loss of electron here, there is going to be 5 electrons, okay, they are going to be lost. So in this case, we are going to actually write down there's going to be 5 electrons being lost. Okay, here it means that, okay, ammonia has lost 5 electrons, so +5 electrons. Okay, forget about the nitrogen and so on, just actually leave it just like that. So it means that what I can see here, okay, because of this number, I can see that for every nitrogen, yeah, for every nitrogen atom, there is going to be 5 electron has been lost. Okay, every nitrogen atom, that's going to be 5 electrons being lost. And then if I look at the second part here, I notice that there is going to be -2. That is going to be reduction, is gain of electron. It means there's going to be 2 electrons being gained. Okay, 2 electrons being gained by 1 atom of, okay, by 1 atom of oxygen. Okay, 1 atom of oxygen. So now, please take note, we are not dealing with 1 atom of oxygen. Okay, please take note. This one is going to be 2 atoms of oxygen. Okay, so this one, instead of writing it that way, okay, this one is supposed to be for every 1 atom of oxygen, you are going to, okay, this one is lost, okay, and you are going to gain, okay, 2 electrons. Okay, 2 electrons, okay, gain for every 1 atom. So in this case, you are going to have 2 atoms of oxygen here. So instead of going to be 2 electrons, there's going to be 4 electrons that's going to be gained. So for O2, you are going to gain 4 electrons. Now, ignore this part. We can actually balance it later. Yeah, because 2 oxygen and then 2, no need to worry about that. Now we just need to worry about the number of electrons. Now if you look at the number of electrons, that's 5 and that's 4. Okay, so here you see on your right hand side, okay, of the equation, there's going to be 5 electrons, and then on your left hand side there's going to be 4 electrons. So we need to actually eliminate these electrons. So how do we eliminate the electrons? Okay, we eliminate by finding the lowest common multiple. So the lowest common multiple for 5 and 4 is going to be 20. So I'm going to times this by 4, and I'm going to times this by 5. So what am I going to times actually here? Okay, I am going to times this by 5. Sorry, I am going to actually times this, okay, with 4. This reaction for, I need 4. Okay, why? Because I need 20 electrons. I am going to times this by 5. It means, okay, I am going to times this by 5. The reason why I did that, because I need 20 electrons. Okay, so it will cancel. So what I get over here is, okay, as simple as this. You are going to have, okay, 4 NH3. So you just need to write this as 4. Okay, we have identified this as 4 and this is 5. So we have identified X is going to be 5. So you just need to put 5 there. So the rest you just need to balance. Like for example, what is going to be Y? Quite simple. You have 4 nitrogen. So I just need to put 4 here. Okay, so I'll erase the Y and I just need to put 4 here. Okay, 4 nitrogen. And then, okay, the next is going to be to balance the oxygen. The oxygen, you can see here, there's going to be 10 oxygen here. So here I have 4. I need 6 more. Okay, so how do I get 6 more oxygen? I just need to put 6 there. And the last thing is to check for hydrogen. Hydrogen, there's 12. And hydrogen here, there's 12. So this one, we have balanced the reaction, okay, by using the oxidation number. So this is going to be the balanced reaction.